If you recall from part 1, we call a music string a harmonic vibrator because it produces a series of tones when it vibrates. Those tones are related to one another by integer multiples. But if you also recall, I used the word theoretical string. In reality, a music string isn't exactly harmonic. The set of frequencies produced are actually a little bit different from exact integer multiples. That difference is called inharmonicity. The inharmonicity factor is a kind of complicated function of the string's bend properties, its diameter, length, and tension. A real string doesn't actually vibrate in the way we picture it, like a nice sine wave or a jump rope. What happens in terms of the harmonic frequencies is that the numbers get a little bit larger as you go up, so that the A110 string actually will vibrate a little bit more than 220 cycles per second, and a little bit more than 330, a little bit more than 440, and so on. That A110 string in different pianos will have different inharmonicity factors. I recently measured the strings of 3 different pianos. A beautiful 9-foot concert grand had a 54-inch A110 string, and if my calculations are correct, the inharmonicity of that 4th partial is about 1.6 cents, and the 8th partial 6.7 cents. In other words, if that string is tuned so that the fundamental is 110 cycles per second, then that 8th partial isn't really 880 cycles per second. It'll be a little bit more. As a piano gets smaller, the strings get shorter and thicker in order to produce the equivalent notes. So the A110 in a little spinet piano is only 30 inches long, and the string is thicker, so the inharmonicity is a lot more. In part 2, I said the octave interval is tuned so that all the partials coincide with each other, and there are no beats. But I also used the word theoretically. In reality, inharmonicity presents a problem here. The small grand string from a couple of slides ago has inharmonicity such that if you tune that A string at exactly 110 cycles per second, the 4th partial will vibrate at about 440.7. So if I wanted that partial to land on A440 exactly, I would have to tune the A110 string down a little bit. Similarly, if I wanted the A220 string, 2nd partial, to land on A440 exactly, I'd have to tune it down a little bit too. Great. But things are still a little bit messy because the inharmonicity of a string gets even worse as you go up in partials. So the partials of those 2 strings that are supposed to be 880 are different from each other. If you've heard the term stretch, that refers to the idea that the lower notes of a piano are tuned a little bit lower than theoretical, and the high notes are tuned a little bit higher. So, how does a tuner deal with this stretch thing and deal with inharmonicity? Well, let's consider that octave A110 to A220. If you play them, you're going to hear all their partials, including, say, the 4th partial of the 110 and the 2nd partial of the 220. Call that the 4-2. Also, you'll hear the 6th partial from the 110 and the 3rd partial of the 220. That's called the 6-3. And there's more partials down below and up above, so on and so forth. Ideally, all the partials are going to coincide, but the principle of inharmonicity dictates that when one pair of partials coincides, the other ones will not. So there will be beating somewhere, and the beating will be worse when the inharmonicity is worse. Now, if your job is to minimize all the beating, a rule of thumb is down in the bass, that 6-3 beat is one that kind of stands out and should be minimized. In the higher part of the piano, the 4-2 stands out. And in the middle of the piano, you tune it so that there's kind of a smooth transition from one to the other. Now, that's just kind of a rule of thumb. Stretch is a subject where there is subjectivity, and there are different philosophies among piano tuners. Some will say octaves need to be tuned to be beatless, while others will point out the fact that that's technically impossible if the piano even has minimal inharmonicity. The best we can do is minimize the beats that stand out and also make the piano sound continuous and smooth from note to note as you go down. Those two goals may actually conflict if you have a particularly difficult piano, such as a small spinet. Meanwhile, some players will tell you that they like more stretch because the low-pitched beats down there contribute to the richness of a sound. Another interesting thing to note is that there's a phenomenon in human hearing where in the higher ranges, a stretched octave actually sounds correct to the ear. As another little aside, organ pipes have no inharmonicity at all. So organs are not stretched when they're tuned, and that's why piano and organ duets often sound a little bit goofy. If we go back to the temperament tuning, remember how all those intervals had a beat rate? Well, guess what inharmonicity does to that? It stretches all those little intervals a little bit. So all those beat rates are actually a little bit greater depending upon the piano. Great. So now we have an even more complicated Rubik's Cube where you're not even sure what color the little squares are, right? So what's a tuner supposed to do? Well, all those intervals are done in a relative way rather than exact. So, for instance, the contiguous thirds like this successively beat relatively faster. For instance, for every 4 beats of the FA, the adjacent A C sharp beats 5 times. And another example, the major third and the center of a major sixth like this are just about equal in their beating. So this isn't an exact science. You just have to make sure all the intervals in your temperament are all as good and consistent as they can be. And sometimes that demands compromise, especially in small pianos. So is piano tuning an art or a science? Well, I think if not for the inharmonicity, it would be a science because you would tune all your notes precisely according to theoretical values. But inharmonicity puts a little bit of imprecision in there. That imprecision makes your science not such an exact science. It brings in a little subjectivity, it brings in a little conflict, and that's like bringing in a little bit of spice to life.